Okay, hello and welcome to From Zero to EKS in Spinnaker using Terraform and Kleat. My name is Rob Hilton. I am a Principal Solutions Architect with AWS, and I'm joined by my esteemed friend and colleague.
Hello, everyone. My name is Nima Kaviani, Principal Solutions Architect with AWS, and happy to talk to you about Kubernetes and deployment of Spinnaker.
Nima and I are longtime open source fans and also longtime Kubernauts, and we spend a lot of time annoying each other debating about these topics. And we thought it might be fun to have a conversation about what it takes to get started with operational toolchains like Spinnaker on Amazon EKS. Now, these are both fairly mature tool chains, so I think the initial question everyone might have is, how hard can it possibly be? And on the bright side, I think this is going to be a short talk. Nima and I will be telling you that it's super easy. There are only a few minor knowledge prerequisites that you need to have in order to have a fully functional production-ready version of Spinnaker on EKS with all the bells and whistles. First things first, if you're going to be working within AWS, it's useful to have some understanding of AWS VPC networking and load balancing. Also, if you're going to make it repeatable, it's useful to have some knowledge of some infrastructure as code tool chains like CloudFormation and Terraform. In order to effectively monitor and observe our infrastructures and our Kubernetes clusters, we should also have some understanding of insights tool chains like CloudWatch. But in order to get information off of our clusters into CloudWatch, we need to have some open source tool chains attached. Um, Also, if we're going to be doing some other work with orchestration, we're going to need to have, um, okay, I guess it's not quite as easy as I thought it was going to be. Um, I think the fair question here is why is it so annoying? And I think Nima has some thoughts about that.
Yes, Rob, I can for sure tell you why it's so annoying. It's annoying because you require different skills for different layers when it comes to deploying your software. So if you're dealing with the infrastructure, depending on whether you use Amazon or a different cloud provider, you need to have the infrastructure level skills. So you need to know whether you're going to use CloudFormation, whether you're going to use Terraform, CDK, or any other tool, right? Then we move on to the next layer for the orchestration engine and for managing your containers, what you're going to have need to do, whether you need to use Kubernetes or ECS. And even then, how do you bake your Docker images? How do you deal with manifest? How do you deploy your software to Kubernetes or a different container engine? Are you going to use Helm? Are you going to do some sort of customization? And then you need to think about operation and bringing everything together, right? So are you going to do something with CI/CD? Are you going to use Spinnaker or Jenkins or Flux or a different platform? Or are you going to do it manually or basically just hope for the best when you roll your software from one environment to another? Or maybe actually CNCF can tell us what to use, right? So let's look at the list of software that they have. Oh well, there's like 1,000 different ways you can configure things according to CNCF. There's literally 10 or 15 or 20 different software and toolkits for different areas in deploying your software system when it comes to Kubernetes, right? So it can get out of hand very quickly. But let's put things into the perspective, right? There are different lenses through which we can actually look at all the software that's available for us to configure our application and our infrastructure. But one of these lenses or perspectives is to whether to use imperative deployment strategies or whether to do it declaratively. So by imperative, what we basically mean is that we define the set of steps required for us to get our software to a stage where it's actually ready to go. By declarative, basically what we mean is that we're going to define the end state of where we want our system to be, and then we let the platform take care of it for us, right? So there's been a lot of tooling in both areas, as you see in this slide. But one thing that is particular about Kubernetes is that Kubernetes is heavily declarative system. You define the end state of your resources and your infrastructure, and Kubernetes just gets it there for you. So maybe there is a simple strategy for us where we can actually declaratively define everything that we require in order to get our setup for a Spinnaker using EKS going, right? So we're hoping that we found a way, and I'm going to hand it over to Rob, who's going to tell you how this can be done.
Thank you, Nima. So, as Nima suggested, now we have to figure out what the answer is to this potential challenge that we find ourselves in. But before I tell you what the answer is, I want to introduce you to this empty AWS account. This account will be following along with us for the rest of the demo, and it's going to be showing us exactly what should happen in a perfect declarative world whenever we want to deploy EKS and Spinnaker together. Now, as this goes through and showcases the account, we have to figure out exactly how to get started. And the first thing we need to understand is that most of the layers that Nima talked about, from the infrastructure to the orchestration to the operational layer, share some characteristics. So even though their domain-specific languages may be slightly different, most of the information we need to provide is more or less the same. So in order to make a declarative execution of EKS and Spinnaker, we have to figure out what exactly we need from the perspective of variables to be able to pass to all of these individual layers. And the list isn't as big as you might think. We really just need to tell the environment what AWS region we're going to be running in. In order to make it externally accessible, we need a domain name that's specific to our environment. In order to store Spinnaker's configuration information, we need a persistent store like Amazon S3. In order to make things a little bit more convenient and portable, we're going to need a Git repository. And optionally, if you're going to be using this repeatably, it's useful to pre-configure your SSH keys in Git repository authentications. The practical reality is this is a relatively small configuration file that you're going to be able to see deployed in our environment right here. So now that we know we have things we want to declare, I want Spinnaker, and I want EKS, and I want all of its quality of life improvements, let's take a look at how this example stitches these things together.
Okay, so let's go over what's happening here. Basically, what we want to have is that we want to start with AWS, with an account in AWS, and we want to end with a Spinnaker. So there are a number of steps that are involved. And the idea for us is that we provide a bunch of configurations to the toolset that we provide. And eventually we go through all the set of steps necessary to get the Spinnaker, right? But at the very beginning, what it involves is to set up our shared infrastructure resources and also to have Kubernetes on top of this. Fortunately, for that purpose, we can use Terraform. And what Terraform allows us to do is that we can define the configuration requirements through a domain-specific language that Terraform supports, which is called HCL. And then we can use HCL and through it bind to the endpoints for the AWS provider and spin up Kubernetes resources. So this is all taken care of by Terraform. But one thing that is interesting is that the toolset that we have in place actually facilitates the set of steps that you require to take in order to get from an AWS account to a Kubernetes cluster up and running. So even though on the surface, everything is declaratively defined through configurations by the user, underneath it, we actually take the set of necessary steps imperatively in order to get a Kubernetes cluster up and running. And once we have Kubernetes cluster, then we can also use Terraform for Helm configuration so that we can deploy Flux on top of this. And this allows us to then delegate to Flux to take care of the rest of it for us and do the GitOps behavior. So Rob is going to tell you why that GitOps behavior and why the operations at that level is important for the rest of the execution of this tool set.
So now that we understand a little bit about how we're going to be deploying Spinnaker in Kubernetes, I think it's worth understanding why we've chosen some of the tools that we did. Specifically, why are we using things like Weaveworks Flux to deploy something like Spinnaker? And what's the impact of something like DevOps and GitOps and DevSecOps and all of the opses? So in order to do that, I've decided to give you a bit of a textbook lesson. Let's explore the opses together. First and foremost, DevOps. The definition is a set of practices intended to reduce the time between committing a change to a system and the change being placed into normal production while ensuring high quality. GitOps. A paradigm or a set of practices that empowers developers to perform tasks which typically fall under the purview of IT operations. You got it? There's going to be a test on this later. Super simple. Makes all the sense in the world, right? But let's take a look at a few examples before we go deeper First of all, I would say for the case of delivery, Spinnaker is considered an example of traditional DevOps. However, also for delivery, Weaveworks, Flux, and Argo CD are examples of what are being defined as GitOps. And if there were one lesson I wanted you to take away from this slide in particular, it's that those definitions don't matter at all, and they are not mutually exclusive things. As with all tools across this ecosystem, we're challenged in the fact that you need to have specific considerations depending on your workload, organization, and flow processes in order to decide what tools are the best fit for you. And the reality is, it might be a combination of both, as it was for Nima and I in this specific tool chain. So, for example, the questions you should be asking yourselves are, what individual components do your tool chains need to interface with? Is it just Kubernetes, or do they need to touch other infrastructure bits like AWS EC2, Route 53, or other cloud providers? Additionally, what changes do you want to capture as an organization? Do you want every single adjustment that you make to your infrastructure to be recorded in version control, or do you want your developers and operators to have the freedom to do more flexible testing without having to follow strict Git-oriented protocols for each and every one? And are your configurations portable across platforms? Are you only using Kubernetes, or do you want to be able to run these on different types of infrastructures? And last but certainly not least, how dependent do you want to be on that underlying platform tooling? Do you expect Kubernetes to manage every bit of the infrastructure using its own abstractions, or are you looking to control things more natively with their own APIs? And the practical reality is this is not going to be the same for each individual person. So I can hear you out there asking me to be more specific. So I'll give you examples based on the choices that Nima and I made. For example, Kubernetes specific configurations that define relatively static states. I would choose things like Flux for that. For example, quality of life features for EKS like container insights and ingress controllers and load balancer managers and other things that are going to be relatively static and always specific to Kubernetes are a good fit for things like a GitOps model. However, for complex, highly portable flows with a bunch of underlying dependencies, pipelines that go through multiple different stages, touch multiple different Kubernetes clusters, or interface with things directly like Route 53 or things that there isn't easy pluggability from Kubernetes, that's where a delivery toolchain that specializes in those types of interfaces makes the most sense. And that's where Spinnaker is perfect. So for our use case, we've more or less chosen to use the best tool for the job using both of those paradigms. And more or less what we've created is a way to minimize the cycle of abstraction that typically exists. So what we're used to is the fact that we know we need infrastructure. So because we know we need infrastructure, we want to abstract that infrastructure with something like Kubernetes. But Kubernetes isn't always super friendly to developers who want to do repeatable functional testing and want to actually have more dynamic automation. So we want to abstract some of those redundancies away using a tool chain like Spinnaker. But in order to deploy Spinnaker, we have to be an expert in Kubernetes. And in order to deploy Kubernetes, we have to be an expert in our infrastructure. So what we're trying to do with this tool chain is provide one declarative place for you to define all your criteria one time and let the open source tools that have grown into maturity actually solve those problems for you. Now that we've gotten to this point, though, we have to get from Flux to Spinnaker. And that might sound like an easy proposition, but it's not quite as easy as you might think. In theory, we want to be able to put native Kubernetes manifests into our Weaveworks Flux Git repository, and then use Kustomize to be able to deploy those manifests out into Kubernetes, and then theoretically at that point, stand up Spinnaker. And while we are going to do that with this tool chain, it wasn't always quite so easy. Nima, can you tell us why?
It is easy to assume that you can actually have everything defined declaratively for your infrastructure, for your Kubernetes cluster, for your Spinnaker deployment, but things haven't been as easy. In fact, if you consider the Spinnaker ecosystem alone, you would notice that previously the community used a different strategy to deploy Spinnaker. One of the superpowers of Spinnaker was that it actually could interface with different cloud providers. So you could use it to deploy to AWS, you could use it to deploy to Cloud Foundry, you could use it to deploy to GCP. And all of that was the result of a Spinnaker being able to tap onto the APIs for these different cloud providers and then set up the infrastructure. This was done through a tool called Halyard. So Halyard would actually bring in the power of a Spinnaker and then would allow for deployment of it against these different cloud providers. But the thing with Halyard and the use of the APIs for the cloud providers was that by nature, Halyard was an imperative tool because it had to follow a certain set of steps in order to get all the microservices for Spinnaker installed, get the configuration going, and ensure that finally your system was up and running. And so when Kubernetes came about, there was disconnect between the way Kubernetes preferred or allowed the deployment of software and the way Halyard was structured to deploy stuff. Kubernetes is primarily a declarative system. You define the end state of your software, and then you get what you want from the platform by providing it the specifications. So for the users of a Spinnaker, or for the users of Kubernetes, when they came to deploy a Spinnaker, there was a disconnect of understanding between how they would interact with Halyard and how Kubernetes skills that they had would allow them to get the Spinnaker up and running. And that wasn't desirable. So that's why the community started moving towards a new set of tools in order to make it easier for the Kubernetes developers to have a more declarative approach to deploying Spinnaker. And that was through the use of Kleat and using Kustomize. So by that, basically what you can do is that you can define the configurations for your Spinnaker microservices and combine them with a bunch of templates, overlays, and a structure that Kustomize enforces on your deployment, and then use the existing Kubernetes toolchain to deploy a Spinnaker. And by doing so, you can actually a lot more easily have a better understanding or have a better way to deploy your Spinnaker setup onto Kubernetes and bring the existing Kubernetes skills into setting up Spinnaker. So that brings Rob and I one step closer to be able to have an end-to-end declarative system for deploying everything, including your infrastructure, Kubernetes, and Spinnaker through one set of tools and one way of doing the deployment. So with that, I'm going to hand it back to Rob to show you what exactly we can achieve through that.
As you can imagine, this gives us some fairly unique options that are available to us in configuring the life cycle of Spinnaker. So to showcase that, we've deployed out Spinnaker just with basic authentication, the same username and password for everyone, as you see. Now, no one in their right minds is going to use this kind of configuration for production. So let's explore what it looks like to take this configuration of Spinnaker as it stands and to use a combination of Flux and Kleat to make a change using Git. So the first thing we're going to do is we're going to find our Halyard configuration file, which is the configuration file that Kleat takes in order to make adjustments. The same configuration file you're used to if you're using Halyard CLI to deploy Spinnaker. We're going to make a change to the Halyard configuration file where we're going to add a setup for OAuth 2. We're going to configure to a G Suite environment and make sure that we authenticate to a specific domain. All we're going to do is we're going to paste in our OAuth 2 configuration into our hal config file. We're going to use Kleat to generate a new set of configurations. Those configurations are going to land in our Git repository. And then we'll be able to diff and see exactly what changes are being made by Kleat. Then at that point, all we have to do is commit to our new Git repository, push it upstream to our origin, and then when Flux syncs next time, it will replace all the appropriate Spinnaker microservices and create a new installation that uses OAuth as its authentication method. And you can see that all we have to do is refresh Spinnaker online, log in, or log back out, log back in, and we'll see now we have a nice, shiny OAuth 2 login instead of our basic auth. So now that we have an idea of how to deploy out a declarative pipeline for EKS and Spinnaker, and now that you've seen this cool thing that Nima and I put together in action, the next obvious question is, What do we do now? And fortunately, the answer is easy. Play with it yourself. You can find this example code and the toolchain it deploys, which we've lovingly named Loom, at this GitHub URL. Now, as you're working through this toolchain, please keep in mind that it comes along with some caveats. This is a very, very early example of how these fully declarative flows can be realized across AWS, EKS, and Spinnaker. This applies to a variety of other application types and is compatible with a number of different cloud providers. But the fact that it is early and it is a prototype means that it comes along with some gaps and potential opinionated choices. For example, right now this version runs on Kubernetes 1.15. Now, that's an older version of Kubernetes, and we intend to change it to more modern versions. But do keep in mind if you're going to adjust the Kubernetes version yourself, the reason we're holding at 1.15 is that due to changes in the Kubernetes API, each minor version of Kubernetes needs attention to the manifests that are deployed with it to maintain functionality. An example of that is cluster autoscaler. Its behavior differs between 1.15 and 1.16, so handle with care if you increment the minor version of Kubernetes on your own. Secondarily, there's some security practices here that would not be considered best practice. For example, the permissions inherent currently still use instance profiles for permissions to access things like S3 and Route 53, as opposed to using IAM roles for service accounts, which is a feature that's available in EKS. We want to change that eventually, but we used instance profiles right now to minimize the number of ARNs that needed to be in our Kubernetes manifests. Should you want to explore what that looks like in your own environments, IAM roles for service accounts is actually enabled on the EKS cluster when it gets deployed. You don't need to make adjustments inside the manifests themselves. Last but not least, when we put this together, we were greatly opinionated in its configuration. We surfaced very, very, very few customizable options in the top level configurations. So if you want to make adjustments, for example, to the instance types in use or the number of maximum and minimum nodes in your EKS clusters, you'll need to drill down into the Terraform manifests in order to find those options. However, the most fantastic thing about this being an open source tool is that those are simply Terraform manifests and you can make any changes to them that you want. Last but not least, have fun and give us feedback. Thank you so much for joining us for this talk, and please let us know what you think.